Hi, I'm going to give a demo of our demo paper, Unsupervised Question Duplicate and Related Questions Detection in e-learning platforms. E-learning platforms have large databases of questions that they store to gauge the learner's understanding of different concepts. This repository of questions has to be constantly updated in order to ensure a diverse pool of questions to conduct assessment for learners. However, a common problem that they all face is that there are a lot of duplicate questions inside the database. This not only takes up extra storage in the database but also worsens the user experience. As a result, we worked on an application that can detect duplicate questions in a large database of questions and can help e-learning platforms to get rid of this problem. Now I'm going to explain how does the application work. So let us assume that the user inputs a question. This question is taken, and first of all it is pre-processed. This means that we remove punctuations and replace chemical symbols by their full names or some special characters with their complete forms. Let's say pi symbol is replaced with pi and H is replaced with the name hydrogen. As a result, we have a pre-processed input question that we can further use in order to compare it with the rest of the database. Since the database can contain questions from different subjects and different fields of expertise, first of all, we try to prune the search space by detecting what subject does the input question belong to. For this, we are using an application developed by one of the authors called TagRec to predict what subject and more specifically what chapter does a question belong to. Since all the questions in the database have already been uh, pre-processed as well, we know what subjects they belong to. We can now shorten the list of questions that we must compare our input question with, and this results in higher efficiency and accuracy as well, as seen in practice. Once we have pruned the search space, the next part is to extract keywords and named entities from the input question. Again, all the questions in the database have their keywords and named entities extracted. So once we have also extracted these entities for the input question, we can compare an overlap between the keywords of the input question and the keywords of all the questions in the database. For all the questions that have an overlap larger than a certain threshold, we still keep them in the search space. Rest of the questions are dropped. The next part is to compare named entities. As we saw in practice that for two questions to be really duplicates, the named entities have to be the same, because let's say a question, should I study medicine in India and should I study medicine in USA, would have two different named entities, USA and India, which completely changes the question as well. The same happens with different subjects of question, let's say chemistry, physics or maths. As a result, we only keep those questions in the search space that have the same named entities, the same set of named entities as the input question. Once we have this, the final step is to compare if the questions in the database that we are still considering and the input question have the same level of negation. So let's say there are two questions: should I study medicine in India or should I not study medicine in India? These two questions have different answers and hence cannot be considered duplicate. For all those questions that have the same negation, we define them as duplicate and show them to the user. However, an extra feature of our model is that it also shows related questions to the input question. This can be used in multiple ways. So let's say that the user experience might get better because the user can also check his knowledge in the same topic but from a different perspective. So this could help first of all in user experience as mentioned, and it could also help in making sure that the model is not missing any duplicate questions, because two questions which will not be duplicate might appear in related questions, and for the person who is cleaning the database this gets much easier. Related questions are found by representing the input question as the question embedding. We also have the embeddings for all the questions from the database, and we find the closest embeddings by using scanNN, which accelerates this large scale inference and allows us to process an input question much faster. Now let us give a demo of the model itself. So this is what the interface looks like right now. we have to enter a question, and we might also enter the answer of the question. So let's say I enter a question, calculate the mass ratio of oxygen and carbon in carbon monoxide. So let us quickly enter the question. The model starts to look for duplicates, and within a short period of time we might get all the question duplicates. So it has found two duplicates. One is an exact duplicate, which means that the questions every word matches, and the second duplicate is not an exact duplicate but is still a duplicate because the answer for both these questions can be the same, and both are very similar. However, as mentioned, we also show related questions. So as you can see, these related questions are very good for the user, which might be a student, to test his understanding of the topic, since these questions are belonging to a similar topic but are asking different perspectives of the topic. So another thing that our model provides is, because databases are often saved as CSVs, we can directly send a CSV to the model and it might give the all the duplicates for the provided question. So let's say I have two questions here. I download this as a CSV. Once I have downloaded it, I have to upload it. So we can download it from here, and we can submit the question. So I had submitted two questions: what is force and what vitamin is fat soluble, let's say. So this has given us an output. We can download the output and quickly see the output here. So it has given us the question's output. So what is force? It found two duplicates. What is force? What is the weakest force? And also found related questions. So these are not. And similarly, what vitamin is fat soluble gave us two duplicates and related questions. The third feature of our model is that, as you might have seen, that there is this answer input box here. So let's say I enter a question, the same question. Let's say a question: what vitamin is fat soluble? So if I do not provide any answer, it will go through the same path as we have seen before. So it gave us two duplicates and two related questions. Now let us assume that we provide an answer which does not make sense at all, but computer. We say computer, and let the output is showing zero question duplicates. However, the duplicates that we saw before are in the related questions. Now the point of this is that, because an answer also plays a role in determining if two questions are duplicate or not, if two answers are not related at all, there is no point in definitely saying that two questions are duplicates. So because these two questions that are in the database have their answers, which, if my biology is correct, is vitamin A, it compared the answer of these questions and computer, it found no relation, and hence moved these questions from duplicates to related questions. So when somebody is cleaning the database, they might see them here and determine themselves if these should be classified as duplicates or not. However, let's say I answer the correct answer. I say the correct answer is vitamin A. It now has shown the question as the question duplicate. What is a fat soluble vitamin? Because its answer would be similar to this one. So as we have seen through the demo, the model works fast enough in order for the user query to generate duplicates and find them in a large database of questions. Since we had over 100,000 questions in the database, and it is taking not in a lot of time in order to find the duplicates, this model can be considered, this model is quite efficient and accurate. We did a couple of surveys, and the accuracies are also provided in the demo paper itself. In the future, this model can be used in order to generate large scale databases of duplicate questions or sentences, and also can be deployed by e-learning platforms. As well as that, we are using this model to generate data for training a bioencoder that would be able to perform the same task, and hopefully in a more efficient manner. Thanks a lot for your attention.